Hello, Timothy Christian Pre-Calc class. I wanted to clarify something from the last video that I gave you. If you got 100 on this assignment, you can sign out. Have a great weekend. If you have not received a grade, it's either because I didn't get your submission yet or it was incorrect. Please watch this video. So the last thing we talked about was the power reducing identity. I have some function, that's what this F means, or you could talk about a formula. This may not be a function, right? May not pass the vertical line test. But I have some formula that uses cosine squared theta as an input. And I want to rewrite that in terms of cosine of 2 theta instead. So this F simply means that I'm substituting out cosine squared theta in this expression for an equivalent expression that uses cosine of 2 theta instead. And the goal here is to find the relationship, the substitution formula that I will be able to use. And we did the work last video. You saw that the final answer was that cosine squared of theta could be written as 1 plus the cosine of 2 theta, all divided by 2. I want to go through some points again from that derivation. First of all, we start with the sum identity because it's going to allow us to get to this relationship at the bottom. The cosine of 2 theta can be written as the cosine of theta plus theta. Okay? In the sum identity formula, you see theta 1 plus theta 2. Okay? That's the official formula. But when your argument is 2 theta, that means theta 1 equals theta 2. So I don't need to separate them with different subscripts because they are the same angle. Now, we can still apply the formula, and as we did last time, when you have the same angle, you can simplify a great deal. So this cosine theta times cosine theta becomes cosine squared theta. And likewise, the second term becomes sine squared theta. Now the next step is to use the Pythagorean identity to substitute out sine squared theta on this side of the equation. So first I have to find the substitution, the correct substitution by using the Pythagorean identity. Remember, we start with cosine squared theta plus sine squared theta is equal to 1. That's where we start. Okay? From here, I solve for sine squared theta in terms of cosine squared theta, and that's how we end up with 1 minus cosine squared theta is equal to sine squared theta. You have to do that same step I just did and solve for the cosine squared theta term now to get the other version of the Pythagorean identity. So you'll end up with some expression that says cosine squared theta is equal to 1 minus what? Okay, going from the Pythagorean identity, solve for the cosine squared theta term, and you'll end up with an expression here that has sine squared theta in it. That's a lot of hints. Once you have this, you go in and substitute this expression here for cosine squared theta. When you simplify it, you will end up with the cosine of 2 theta on the left, because we never changed that, and something on the right in terms of sine squared theta. Now, the sine squared theta term can be solved for in the same way that we solved for the cosine squared theta term last time. So when I solve for it, what I'm going to see is that I'm going to get an expression, okay, on the left, when I'm going to solve for sine squared theta after I do all the work here, I'm going to get an expression on the left that says sine squared theta is equal to some formula that has cosine of 2 theta in it. It's going to look very much like the one we had for cosine squared theta, except for one small difference. Now, what we have done after you do this assignment, you will see that you now will be able to write any function with a sine squared theta term in it as a function of cosine of 2 theta. Make sure you're keeping the cosine of 2 theta in your final answer. Some of you thought that you needed to replace this with sine of 2 theta. That is not the assignment. Okay? So it's a very easy assignment. I hope that this helps you so you can get a great grade for the final homework assignment of the quarter.